Good evening, everyone. Welcome to this Sunday, October 27th evening session of the Fireside Chats with Carlton. No, just kidding. the so we'll be basically dealing with GA4 and week 4 content today. And let's me share my screen. Share. Okay. Okay. Mm, no, I didn't realize it's been put on GitHub. Okay, anyway, makes no difference. The same difference. Right. So week 4 is about data analysis, and I hope you've had some time to go through some of these videos. With regards to things like Excel, what I will say is uh, the content that's actually in the videos, you will at least be expected to know about it. Although I recognize that some of you will not have Excel itself, but whatever they've covered in there, at least just be aware of what it is and how it works. So for example, when he was doing the correlation analysis, just pay some particular attention to what functions he used and how he managed to get it. Okay. Same with regression with Excel. Same deal. Again, forecasting with Excel. Um, uh, these are all Excel related things. So there's not much for me to go over because it'll just be a repetition of what's in the video. So I'll not necessarily do that. Uh, then, of course, this I think almost every week we have been covering, right? Data analysis with pandas, and there's a reason for that because it's very useful to know pandas for almost everything in terms of data analysis. It is sort of the de facto industry tool for a lot of data analysis. Okay, so since we are doing this anyway, I won't specifically talk about this because even today in the GA4s, we'll again be using pandas to deal with it. One thing you will notice is there is something called Parquet files. This is, I don't know how new this is, but this is newer than CSV anyway. And the specialty of Parquet is, unlike CSV, which basically you deal with on a row by row basis, Parquets are unique in that they are designed for handling on a column-wise basis. So it enables for some extremely efficient storage and processing. So that's why Parquet files are very much in vogue at the moment for handling large amounts of data because of both the performance benefits as well as the compression benefits that you get from handling files in a column-wise fashion as opposed to a comma separated value method. Okay, so that's just something to know about Parquet. And the other thing is, if you're handling Parquet files in Pandas, you may, sorry, in VS Code, you may have to install a library called PyArrow. If you're in Google Colab, it'll work straight away without any issues because Google Colab already installs most of the important libraries anyway. If you're using VS Code, you might have to add that extra library called PyArrow, Pyarrow. So that's just something to keep in mind. And data analysis with databases. Some SQL is useful to learn, of course. There was, I think there is a resource. Yeah, okay, this one. You see SQL Zoo over here. So this is actually quite useful for learning SQL. Okay, why is that not working? Okay, let me just remove this front bit and see. Okay, I don't know why that's not working, but this was quite a handy resource. Okay, so the best way to get this is go to Google, type SQL Zoo, and this is the actual address of it. Very, very useful to learn basics of SQL. I highly recommend going through it. It's worth learning at least the basics of it. Okay. Again, we're not asking you to become experts at it. Just understand some of the basic things. And I think GA4 had an assignment where you work a little bit with SQL, not too much. But that's the things that you saw in that video with regards to SQL. Those are the kind of things you might need to know how to do. Okay. So that's with regards to SQL. But this SQL Zoo is very useful. Obviously, this link is not working. It should be sqlzoo.net instead of www.sqlzoo.net. Okay. And then, okay, this video, data analysis with DuckDB. There is no question on it in GA4. We were supposed to give you a question, but one of the issues was when we were solving the DuckDB question, the GA question, it was deemed too difficult for students to deal with. So we decided to drop the question for DuckDB. But having said that, you should really watch this video carefully and try it out yourself, DuckDB. It's mind blowing what this can do. Now, as far as some of the things that were mentioned in the video, I'm not 100% certain that everything is correct, what Anand said in terms of what DuckDB does and how it does it. But most of it is from the important thing to take out of the video is the immense capability of DuckDB, which goes far beyond many of the other things that most people use on a regular basis. The one thing to keep in mind is, you may ask, okay, if DuckDB is so fantastic as a database, then why don't we just use DuckDB for everything? Well, there's a reason for that. One is DuckDB does not honor. So if you have done DBMS course in the program, you will learn something that's important about databases, which is consistency, atomicity. There's some buzzwords like that. Okay, transactional. I forget what it's called. Isolation or something like that. There are some keywords which basically means whenever you do any transactions on your database, it's got to keep your data secure and it has to be in a consistent state and all that sort of thing. Okay, that's what a traditional database will do. DuckDB doesn't do that. So that's why you can't replace all your traditional databases with DuckDB. So then you may ask, well, if that's not possible, then why use DuckDB at all? Well, there is a good reason to use it. That's because DuckDB is very fast for analysis. So analysis, you don't really care about many of these things like transactional integrity and atomicity and consistency and all. You don't care about those because you're not manipulating data, right? All you're doing is with DuckDB is analyzing data. So for analysis, this is brilliant, super fast, super efficient, and just written for speed, right? And when you're dealing with large data sets, that's what you want, right? So typically DuckDB will work on will not work directly on the main database that's doing the day-to-day process, transactional processing. Right? What will happen is they may take out a copy of that data and then run DuckDB to do some analysis on it. So that's the use case of DuckDB. So just so that you're aware, okay. That might change with time. Maybe they will make it into a full proper database. But for now, that's my understanding of DuckDB. Okay. So for us as tools for data science, this is a great tool, worth learning. Definitely worth learning. You will find great value in it, in DuckDB in your career for sure. Something worth keeping your eye open for. This video is also quite a nice video. It's a seminar that Anand had taken, so it's quite good. Right. So, any questions with regard? I know we didn't actually discuss anything in detail, but this is just to give you an overview of what week 4 is about. Any questions so far?
No.
Okay. What we'll do next then is we'll look at GA4 assignment. So how many of you are here? About 7 people. So how many of you did not do the assignment at all? Okay, so all of you at least attempted it, right? Which is good. All right. Just give me a second, okay? I just need to get this going. Yay. Do that. Open. Okay. Yeah, just give me a second, okay? I'm just trying to get this. It's because I'm not on my usual station that I usually am at. Okay, so I need to open from here, I think. Join. Just a minute here. Okay, I hope it's all good now. Right, so you guys can see my screen, right? So I'm going to try going to the dark side. Okay, use Google Colab and see how it goes. Just because some students are more comfortable with Google Colab, so if I make mistakes, please be patient with me while I try and figure things out. Okay, so first thing is you need that file called flights.parquet, and so we've got that. And the next thing is we'll have a look at what's the question. Say the question says what's the Pearson correlations? I have it here, don't I? Yeah, what's the Pearson correlation between departure delay, arrival delay? Okay, so that's all good. And we also get. Just give me a second while I do a little bit of setup here as well. Yes. No, that's not on. Just bear with me, okay? Wish I had some elevator music I could play now. Let's see. One, seven, yeah, I think this will work. Yes. Okay. Right. So disconnected. You're still able to see my screen, right? Hello?
Yes, sir.
Okay, okay. Right. So the first thing, of course, is we'll need pandas, right? So we go import pandas, oops, pandas as PD. Yeah, that's working. We may need numpy, so I'll just do that while we're here as well. Numpy is np. And then we want to read the file. Now, because we're doing it in Colab, I think this will work without any further intervention. But Normally, if you were doing it in VS Code or something, you would need another um, what you call for it library called PyArrow. So just for completeness sake, I will just add a cell here. I guess this plus sign is it? Yeah. So just for completeness sake, that yeah, I'll just put the name. Oops. Option. Where's the option button here? Hash. No. No. Oops. Okay, that's not working as expected. Right, we might have a little problem here. I mean, remove that. Okay, it's called PyArrow. Okay, PYARROW. But for some reason, I'm not able to use the hash button on this keyboard. Not sure why. Okay, import. So yeah, okay, so PD. When you're using pandas, you would use read parquet. Okay, as opposed to read CSV. And then we can give it the name of the file. And if I remember correctly, it's called files.parquet. Okay, yeah. Flights.parquet. Flights. Okay. Hopefully, oh, flights.parquet is this. Is this not working? Anyone has any suggestions? Who's an expert with oh
I
right.
think there is no need to give space between read
Space.
parquet
Yeah, yeah.
and that.
Yes, yes.
That
It should not make a difference, right? Whether there's a space or not. It's not able to find the file for some reason. I think it's because it's probably in Google Colab, is it?
Sorry, sir, the path of file. Actually, could you copy the path by just clicking on the three dot and then there is the option for copy the path and then paste that because that will work, I think.
That's correct.
Okay. Um, come here. I think I went out too far, didn't I? So you guys are going to have to teach me something today. I've come out of Google Drive.
Sir, you need to be first upload the flight dot parquet first, na?
Yeah, that's what I thought. Where will it go? Will it go into home?
No. Automatically go in. You are in the root directory, so just you have to exit and then load the file. So that file come here. No need to go inside the folder, whatever the Jupyter make already.
Okay. Do you know which? What's the path for where it uploads the file?
By
You
clicking,
can
yeah, by clicking on the file icon where it's the like upward arrow.
or
You're
you can
talking.
just drag it and drop it, no?
Yeah,
From
yeah. You can also
source
be doing
folder,
that.
just drag it and drop it on that panel.
Yeah, you can also do this. Not issue.
Okay. So if I
No, not to go there.
Go to
not
the explorer,
yeah.
and from the explorer, just drag it and drop it in that
Okay. The thing
collab
is,
files
okay.
panel.
The problem is I don't think I have the capability of dragging and dropping files on this device.
Yeah, so
Uh,
so that the better thing I think by clicking the file icon then upload because it is the Mac. I think there is no.
yeah, this is a iPad actually. So I
Oh yeah,
not
this is the iPad.
not try. Yeah. I've not connect to runtime to enable file browsing. Okay. So this is
on
the
the file
folder, right?
upload, yeah,
Yeah, this.
yeah, in the
So
file upload, you can just click on the file upload symbol, and
which is this button here, right? Choose files.
Yeah,
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 And
yeah,
then I
that
choose
button.
this one, say
Yeah,
open.
yeah. Now browse and
Right.
yeah,
Okay.
it's
I
a
think it's
now you can
yeah.
click on the three dots and
yeah.
do copy path,
Okay.
and you have to paste the path inside the quotes.
Okay. Cool. Thanks. I learned something today. Yay. All right. So we got that working. Right. So then the next thing is we want. Okay. So I need to close this now. Can I? Yeah. So we got the DF. Let's make sure it's all looking good. Yeah. So there's the file we expected. Something that might be useful for us also to have while we are here is that and another code is I also prefer to have date time functionality. We may or may not use it, I don't know, but if we need it, at least we've got it. And now there are two ways to solve most of the questions in here. You can either use the decimal conversion to solve the problems, or you can create extra columns. Okay? So although we don't have to create extra columns, I'll just show it because sometimes it's nice to know how to do some extra things you may find useful in a pandas data frame, right? So just for the sake of showing how you go about doing that, I'll make two extra columns. Okay, so the first extra column I'll make, so we can see that all this is in decimal time. So I'll do df and I'll call it hours. Okay, the new column. And all I'm doing is I want to take this scheduled departure, um, and then I want to extract the hour from it. But the thing is, I can't just say dt dot hour, okay, because this is a decimal, right? So it won't work like a normal date time. So instead, I'll use a function called apply. So apply is basically saying apply a particular transformation to the data in this column. So for scheduled departure, I'll apply this particular function. Okay? I'll say lambda, which is an anonymous function, as you all know in pandas, in Python. And I'll say, okay, this x means whatever item is there in that scheduled departure. Okay, so I'll refer to it as x, and the hour is the int part of it, right? So I can just say int x, right? That will just give me the hour. So let's see what happens when we do that. Okay, so it's applying. So let's have a look now at our data frame. And you notice it's made a column, and you can see that it has extracted the hour part from the decimal, right? It's pretty straightforward transformation, right?
Carlton, one
Yeah,
request, if
yeah.
possible, please increase font size or zoom in. It is
Okay,
too
yeah,
small
sure,
to see.
sure. Uh, okay, is that better?
Yeah, it's good.
Okay. So all I've done is created a new column called hours, and you can see that down below. And I've taken scheduled departure, and I've just applied a function to it. Okay, and what is the function I've applied? I've said lambda x, which is an anonymous function, which just takes every item that it uh, gets from the earlier part of the expression, and each item I've just said I want int x of it. I mean integer of that. So and then it'll get that integer value and stick it in hours. And you can see that that's exactly what it's done, right? So it's a simple data transformation. So like I said, you don't have to do this. It's not necessary at all, but I'm just showing you so that you know how to do these simple sorts of transformations, because there may be instances where things like this are useful, right? So we'll do one more. We'll do minutes. Okay. So df dot scheduled departure, and then I want to apply, but this time the transformation is a little more complex. Okay, the decimal part is. Can anyone tell me how you would go about doing the decimal part? If you want to convert it to minutes, the decimal part of the number. It's a simple transformation, right? No, no one's volunteering. Okay, so first thing is we have to remove the hour part, right? So I'll say x minus int of x, right? You agree? We remove the hour bit, and then whatever is left over, we multiply into 60. That'll work, right? No sound today. This is going to be a long and boring session if no one interacts. Am I still on? Not sure. Am I still there?
Yeah, you're on.
Okay. Right. So yeah, so we'll try this transformation, right? Remove the first part of the number and the, I forget what you call it. There's the decimal, and what's the part before it? In front of the decimal, the tens place, is it? I don't remember. Units and tens place or something, right? So we're running that transformation. We can have a quick look. Let's see if it's done that correctly. So yeah, so done something. Question is it done the right thing? Oh, I made a mistake here, right? So this is the mistake. So there was not supposed to be all zeros, right? In minutes, it's supposed to have all sorts of minutes in there. So I accidentally put an extra int in there. So let's try that again. Okay. Oops. Yeah, now it's okay, right? So we got the minutes and we got the hours. So pretty straightforward transformation. No issues there. Something, of course, we always like to do is to check if there are any null values in any of the columns, right? So we can do that. Again, this is not needed for the question, but these are simple things to check for. And I'm talking with it with a view of ROE, right? So there's a isAny function. So all I'm saying is check the data frame if there is any what you call for it, null values in any of the columns. And we can also encapsulate it in a data frame to see what it might be.
Hello, sir.
Yeah.
Could you scroll down the data because it's 59 minutes and 23 hour? How?
Yeah, you can have, right, 23 hours and 59 minutes in a day. Yeah.
I'm thinking it is transformed. Okay.
Yeah, because if you look at the number before it, 23.983, that translates to 23 minutes and 59. Sorry, 23 hours and 59 minutes, right? So let's have a look if there are any null values. Of course, there are. You can see it's showing all the rows that have null values. There's null values in departure delay. There are null values in arrival delay. So that's various things that you can check with your data set. Sometimes it'll be useful to know these things. So that's why I've shown you. So now we'll go and try and solve the first question. Okay. So the first question in GA1 is, yeah, so we have to filter for less than 1,000 miles and schedule departure 15 to 21, right? From 15 and before 21. So that's pretty straightforward. We go, why is this not working? Hello. Okay, something's gone wrong. I'm not able to type. What's happened? Is this working? Yes. Okay. Okay, that's working now. Right. So I'll make a temporary data frame, and then we'll do all our transactions on that. So the first thing we want to do is probably get the distance, right? So the temp df distance, and it was it 1,000? Less than 1,000, right? Yeah, less than 1,000. Less than 1,000. It's not working again. What? Why is this not working? It's very annoying. Yeah, it should be okay. Okay, less than 1,000. Oh, did we not run this? Yes. MTF distance less than 1,000.
I think both variable name are same maybe. Uh,
No, it should work. It should be okay. Oh, there's a spelling mistake. Temp. That's better.
so
Yeah, it was a spelling mistake I had made. Right. So that gives all of them less than 1,000. So let's have a quick look. Okay, that. Oh, sorry, it's temp df, right? Not df. Temp df. Yeah. So those are all less than 1,000. Then we want the hours greater than, I think it was 13, right? No, 15 and 21, I think it was 15 and 21. So we'll do here. Now, because we did the earlier transformation, even though it was completely unnecessary, we can simply use the hours right now because we have it available to us. I can just say hours, and I can say less than, and put, no, sorry, it's greater than 15. And then we can put that in a data frame. Okay, so let's have a look now, see if it's done that. Yeah, okay, greater than 15 is all there. And then we can do less than 23. Oh, was it 23? No, it was, yeah, here. No, 21, right? 21. And temp TF. So there is one mistake I did. I don't know if you guys caught it or not. Did you catch a mistake I did?
Should be greater than or equal to, I think.
Sorry?
It shouldn't cost 15, greater than or equal to 15.
Yeah. That's right, it is. So that's why, see, I deliberately kept on going to see if anyone's going to say anything. As soon as you saw this data frame, you should have recognized that, hang on a minute, you know, it should have like 15, whatever, 5, 15, 10, but it doesn't, right? It starts from 16. So you're right, it should be greater than or equal to 15. So I'll have to run it from here because obviously it's incorrect. So this should be greater than or equal to 15. So now we're getting the right details, right? So now if you look, it's like, okay, it's greater than or equal to 15 and less than 21. So what is the next thing it asks? It asks when filtering, you should get 1, 4, 9, 4, 7, 6, 9 rows. Do we get 1, 4, 7? Yep. So we get 1, 4, 9, 4, 7, 6, 9 rows. So we know that we have filtered the right number of rows. The next thing is use the Pearson's correlation in pandas. So that's quite simple to do as well. I'll say make a new variable called p core. Oops, p core and temp tf. And you can just call correlation, and you can say method equal to Pearson, and it will do the Pearson correlation on all columns with all columns. Okay, that's what this will give us. And if we look at what the output of that is, you can see here it's given us all these figures. And now the question is, we want the Pearson correlation between departure delay and arrival delay. So if you look carefully here, correlation departure delay with departure delay is going to be 1. Yeah, it will be perfect correlation. And then they have arrival delay and departure delay. But they also have the flip side of it. They have the departure delay and arrival delay. And it will be symmetric anyway. Okay. So when you look at the correlation, you can see. So the number that we are looking at, it's 0.952902. So if we look at the question here, yeah, so 0.9529, yeah, so that's what's expected. Yeah, so that's correct, right? So that's it. That was question 1. So similarly, we can do other questions as well. I won't show the other Pearson correlations because that's not necessary, right? They're all similar. The next thing is that was asked was they had asked for the percentiles. Go down here. So this one, percentile. Again, the filtering is straightforward, 1550, starting from 21, but before 22. Because we have made those extra columns, that's very easy. I hope you know how to do IQR, which is the first quartile, second quartile, third quartile. And once you calculate the quartiles, then you will be able to solve the problem. But of course, Pandas has a neat little function. So remember, we've got our original DF still untampered with. So what I'll do is I'll make another temp TF equal to DF here. Okay, so we got back our temp TF. And I'll say temp TF dot describe. Have you used this function before? So what this gives you is, it gives you a what's it called? It gives you a descriptive statistics of everything that's in the file. Okay, there's something wrong with this, and I think I know why. It's because when you're doing descriptive statistics, you got to fill the any nans in there, otherwise it won't work out correctly. So how do we fix all the nans that are in the pandas data frame? You simply use this function called fill NA. Okay, and you can tell what you want to fill NAs with. So in our case, we'll just make them zeros. We'll say in place equal to true, which means I don't want to create a new data frame. This existing data frame itself, I want you to fill all the nans with zeros. So it will do that. And now, if I do temp.df dot describe, we should get some sensible information. Okay, why is it still weird? 5, 8 raised to the power 6. That's not what I'm expecting. 5, 8. 9.2. It's okay. Not quite sure why that didn't work out. Okay, let me try something else. MTF dot say arrival delay, see the median. Let's see what we get. Okay. Maybe that is correct. Might be because of the display, I don't know. All right. Okay, let me try one more thing. So if I do Q3 equal to, so notice I'm using NumPy now. I'll say, so quantile means quartile, okay, in NumPy. I'll do temp.df dot arrival delay, and I can give it, so the third quartile is 75th percentile, right? So if I do this, and look at Q3, so it gives 7. Is that what we are expecting? Oh, okay, yeah. So it says 7 over here, right? E to the power 0. Yeah. So yeah, that's actually, yeah, it looks correct. It's just that I got thrown off by all these exponential that is showing on here, but actually that looks correct. If I do Q1 NP quantile temptf dot and do arrival delay, yeah, 0.25. Look at Q1. Yeah, that looks reasonable, doesn't it? Minus 13. Yeah, it is. Yeah, it is minus 13. Power 1. Okay. Yeah, okay. That's actually working as expected. Don't know why I was expecting something different, but anyway, Q3 minus Q1. That's your interquartile range, and that gives us 20. And now once you have your range, you have your upper bound, lower bound, all those things you have, right? Because Q1, if you want your upper bound, it's 1.5 times the sorry, it's Q1 minus 1.5 times the interquartile range, right? So I'll say lower bound equal to Q1 minus 1 point. It's like it's almost reading my mind. Oh well, thank you. Actually, I better put it in brackets in case it does the wrong things. And then upper bound, same deal, but it's Q3 plus, yeah, that looks right. And then if we just have a look at what it is. So lower bound, if I look at upper bound, okay. So we've got a lower and upper bound, and how do we know what the outliers are? Maybe those that are beyond that, right? So temp TF arrival delay greater than the greater. So we want it greater than our upper bound to get the outliers. No, upper bound, upper bound. Okay, and we want the that's one thing we want. Actually, I need to put this in a data frame. Also, we want the values that come lower than the lower bound, because those are the outliers as well. So lower than the lower bound. Okay, those are our conditions. We of course want to put it in a data frame. So that will tell us all those, and we don't want the rows. We just want the okay. Anyway, we can look at the rows. It doesn't matter. So we can see anything that is above the upper bound, above 37, so that's right. And then anything that's below the lower bound looks right. So less than 43. Yeah. Okay. So we want what we want is the length of this, right? What is that gives? Okay, that seems excessive actually. TF this is an upper bound, lower bound. Okay, that actually does seem very excessive. Not sure where I've made the mistake. Any thoughts, anyone? No sound today. No sound. 581907 rows. Oh, yes. I know what the mistake is. Now I realized. So anyone want to tell me what the mistake is? What, where I've gone wrong? Hello?
Is it and? Sorry.
So,
No.
yeah. So the mistake is, if you look up here, I've done df equal to temp df, right? But then I straight away went into quartiles and quantiles and lower bounds and upper bounds. But I've never done any filtering on it, did I? There was a filter I was supposed to
No.
apply.
Yeah.
1,000 greater than 550 miles and between 21 and 22, right? So I didn't do the filtering. So that's what I missed out. What I should have done is up here, I should have done that filter first. So temp, so if I run this from the top, it's pretty boring, huh, today?
Yeah, we are feeling little tired.
Okay. It's up to you guys. What do you want me to do? Do you want me to keep going, or you want me to do this some other time? Because it's, I mean, if you're not gaining anything from it, then there's no point in me going on, right? So it's your call. What do you guys think? I mean, there's only 4 of you guys here. 1, 2, 3, 4. I think everyone else has left. Just give me some suggestions. I mean, it's 9 o'clock now.
But due to time constraint, we cannot postpone this session. Many people have different sessions, so we can watch recording. Or many
Okay.
people prefer to watch recordings.
Yeah. Are you finding it useful? Have you learned anything so far?
Yes.
Okay, so it is useful, right? I mean, I'm not
Yes.
doing something that you already know, right? Okay.
I just
So
wanted to revisit that how you converted from uh, scheduled departure to hours and minute. But you can do that
sure,
later.
sure,
You can
sure.
leave that code to me later.
Okay. So all I have to do here right now is deal with the filtering. Okay. So I'll try and do this as quickly as I can. Is it greater than 1550? Yeah. So it's greater. It's doing this again. I don't know why when I switch tabs, I lose the keyboard temporarily. Okay, 1550. Oh, sorry, less than 1550. Okay, less than 1550 temp TF. So that gives us the distance, and it's the time is 20 from 21 before 22. So temp TF, temp TF, temp TF dot. And what's it? Departure, scheduled departure. So I do occasionally I lose keyboard. There we go. Schedule departure, yeah, that's it. And we want that greater than equal to 21. I could use an and here as well. So and df dot schedule departure less than 22. Okay. So now if we look at temp TF, okay, that's a lot better. 16163037 rows. And I think it does this automatically. Okay, we'll first try without filling the nans and see what happens. Let's have a look at this description now. These numbers look a lot more reasonable. So we'll do Q3, Q1, interquartile range, lower bound, upper bound, and let's see what we get here. So 15161, is that the answer? Yeah, it's 15161. So that worked, right? It's made because I didn't do the filtering. But this function is useful. Okay, describe. See, that's a useful function. It gives you all the descriptive statistics. So you can see it gives you count, mean, standard deviation, what's the minimum value in that column, what's the maximum value, the quartiles, 25th, median, 50%, 75%. So it gives you all the descriptive statistics of describe. So that's something to just keep in mind, useful function. You might find it useful in ROE. Same way like that, you can do things like, so if you look on here, I've used NumPy and I've done it individually also on a column. So you can see where I've used quantile, and then I've given the column name and what quantile I'm looking at. So you can look at 90th percentile, 80th percentile, whatever you want with quantile. So that's totally up to you. So those are all some useful statistics type um, functions that you can use. You can also combine filters as I've shown here with ORs and ANDs. So those are all useful pandas functions when you're processing things. So I won't do the next question because you now know how to do that. Then comes this regression question. So this is pretty easy, right? Do you want me to show this one? I mean, this one basically all you do is you download the CSV file. You will get 2 columns, and you all know basic regression, right? So you just do the regression on unfurnished. Of course, first you have to filter by Chennai unfurnished houses and filter by Hyderabad unfurnished houses. You'll get 2 sets of columns. And then you do the slope of the rent versus size. So that is a very straightforward computation, right? And just asking, the question says find the absolute difference between these slopes. Do you want me to demonstrate this, or shall we leave this one?
No, it's pretty easy.
Yeah, it's pretty straightforward, right? So I thought so. Okay, so that was easy. This one you would have needed the full version of Excel to do this. Okay, there's no way around it. If you use the forecast.ets function, I won't show it today, but what I'll do is maybe next session, when I've got access to the machine that has the full Excel, I can just quickly, it'll only take like 5 minutes to show you how to use it. Because the reason I'll show it is so that in the exam you know what forecast.ets does. But even if you look at the video, you will see there they do the same thing. They use that function and it gives you the answer. So again, this is a very straightforward one, so I'm not going to deal with that. This next 2 questions, some of you might have had some difficulty with this one, right? So this one I will quickly show you. So what we'll do, so we need, actually we don't need anything, right? We just need the database connection details for that one, right? So we'll do that. So one thing you will need when you are working with databases, particularly in Jupyter Notebook, I mean, there may be other libraries that you can use, but the one I typically use is SQL Alchemy. So I'll import that here. Import SQL Alchemy as, let's see. And all these major libraries Google already has, so you don't have to worry about it. But if you're using VS Code, you'll have to pip install it. So create engine. So this SQL Alchemy object called create engine, you have to pass it a special connection string. And if we go to this repository, it gives you the details about how to deal with it and all the sort of thing. I mean, if you look, for example, in this FAQ and all, they will give you some information about how you access this. But the easiest thing I found, right, uh, some of you might have struggled with it, is in one of the notebooks in the GitHub. Okay, do I have it open? No, I don't have it open. In one of those notebooks in the GitHub for week 4 is a demonstration file. It's a Google Colab file, and it already has the connection string in there, right? So you don't have to like read up any documentation for it. So if you use that, then it's very straightforward. You don't have to do any guesswork or worry about those things. So it's MySQL plus MySQL, and you have to log in as guest for it to work with that public repository. And relationship at db dot relational dash data.org. And this is one common mistake that many students did, is they use the capital R. Okay, after looking at the repository URL that's at the top, they use this capital R. It will not work if with the capital R. Okay, it's case sensitive. The connection string is. So if you fill it out exactly this way, then it will work correctly. Right. So let's do that. Oops, what happened? No PyMySQL. Oh, right. Okay. So we might have to install that. PyMySQL. Okay, so that's installed. Now let's give it a try. Yeah, that worked. Okie dokie. So then next thing you need is to write a bit of SQL. So again, a common thing that people do is they try to write some complex query here and it doesn't work as expected. So I just do a simple thing, right? If you looked at the, if I go here again, I'll just show you real quick. If you look at what the question asks, okay, the question says, Livermore has 70 restaurants, count the percentage of restaurants that serve a certain type of food in each city. Okay, but when you look on here, look at the three tables that it has. Okay, and when you look at these three tables, you can see quite clearly that the information that you're looking for is not going to be in the location table. It's not going to be in the geographic table, but it'll be in the general info table, right? All the information you need to solve this problem does not require the other two tables. It requires only that general info table. So why bother with everything else, right? So just get that table. That's it. Okay, come on, you can do it. Right. And so I say from, and then general info. So this is how SQL commands are constructed. There's a select which tells you what columns you want to look at, and then there's a from which tells which table. So in this case, it's the general information table, and that's it. That's all I want. I want all the columns. The star tells all the columns. Okay, from general info table. That's it. That's all the information I want. Okay, so I put that string in a variable called SQL, and then we want to put it into a data frame, whatever information it fetches, because then afterwards we can do whatever processing you want. We don't want to, now remember, this is just like the API. You don't want to hit public resources over and over again, right? So we'll do the read only once. So that way I'm not sending lots of queries to them. Instead, I'm just getting whatever data I want in one go. So I'm sending the SQL and I'm sending the connection engine into this pandas data frame function called pd.read SQL. Let's run that. Ooh, what's happened? What's happened? Can't connect. Blah, 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 blah. Oh, must have made a spelling mistake. Oh yeah. Okay. Let's try that again. Ooh, still another. Access denied. Okay. What am I missing here? This works for me in VS Code. Just give me 1 second, okay? I'm going to check something. Okay, that's fascinating. So this very same, I guess, yeah, that's correct. Relation. Oh, okay, okay. I made a mistake here also. Relational, I think it is. Let's try that now. Okay, yes, finally. Success. Let's have a look. Yes, so we got the table, right? Now from here on, it's extremely straightforward, but there is something new you have to do here, which is something called aggregation functions. Okay, this is where you group things to get some result. Okay, so I'll just quickly show you how to do some simple aggregation. So one of the things we will need, of course, if you look at the question, is you need what percentage of cities have bar food type. And for to get that kind of percentage, first of all, you need to know the total number of restaurants in a particular city, right? And since there are nearly 10,000 rows, you can't do them individually. Okay, so we'll need some sort of aggregation function to give that information to us very easily. So I'll make a new data frame. Come on, keyboard. So I'll call it, say, city totals. Okay, so it's totals of all the restaurants in the cities, and I'll do, I don't know how it reads my mind, but okay. So there's a function called group by, and then you can tell what you want to group the data by. Okay, so in this case, it's by a column called city, because we want restaurant names for all cities, right? So we'll do that. Um, okay, city. And then what we want to do, group by, but what kind of aggregation function we want to do? We want average number of restaurants, or what? We have to tell it, right? So in this case, I just want a count of all the restaurants in that city. Then let's see what this gives us. Okay, I don't, do we want to reset the index? Probably, but yeah, because when you group by, the index numbers will change. So yeah, let's do that, reset index. And something else we can do as well to make things better. We don't want the restaurant names anymore, right? So when we are grouping by, we're grouping by city. We don't need restaurant names because that will just confuse things. And we don't need reviews or labels, right? So we don't need labels, we don't need reviews. So yeah, so in fact, we don't even need food type, right? We're just counting the number of restaurants. So what we'll do is we'll drop those. Okay, we'll drop those columns. So we'll drop review because we don't need reviews, and we don't need label, which is the name of the restaurant, and we don't need food type. Oops. Okay, and these are all columns along axis 1. Okay, I think that should do it. So all this is doing is group by city, count the number of rows when you group by city, which will give you all the number of restaurants, and then drop the unwanted columns. So that's how it happens. Okay, so let's see this data frame. Wow, great, isn't it? So that tells us, okay, Almeida has 130 restaurants, Alamo has 12, Albany has 38. It's a great little aggregation function, right? Group by column, and I told just count them. So that's what it did. Okay, so we've got city counts. Now, the next thing we want is the food types, right, in each restaurant, sorry, in each city. How many of, say, breakfast ones are there? How many burger restaurants are there? How many cafe types are there? And if we look at the question, I think it wanted bar type. So that's the next thing we want. The uh, basically another group by, but this time we want to do it by 2 levels, right? If you think about it carefully, one is it has to be, if it's just grouped by the type, then that will give you incorrect information, right? It will tell you like, okay, there are 200 bars, but they are from 5 different cities. That's not what you want, right? You want it to group by city first and then by food type, right? So that's 2 levels of grouping. So that's what we'll do next. Okay, so city food we'll call it, and we'll do df group by. You know what? I think my computer hears the words I'm saying. I can't believe it knows that's what I wanted to do. That is very, very surprising. Okay, so food type, because I've never used Colab to do this before, so I don't know how it knows all this. Right, so 2 levels of grouping, city and food type. Again, we'll reset the index because otherwise it will just possibly mess up things. And this time we don't want review or label, right? So we'll remove those columns. Label and it's along axis equal to 1 just means along columns. That should do it. All right, so let's look at what it gives us. So now we've done two group by 2 levels, right? So let's see. So yeah, so you can see Almeida has American food type 4 restaurants. Almeida has bagels 2 restaurants. So that's good. That's exactly the kind of information you want. So now we've got 2 separate tables. Okay, by the way, is there an easier way to do this, or rather a single line or function that can do all this in one go? Probably. Why am I doing it separately? Because I wanted to demonstrate something useful to you. That's why I decided to do it this way. Okay. And the other reason is this is verifiable, right? When you do things, when you break down a problem this way, it's verifiable, right? You can actually see what's happening. So that makes it useful because you know if you're going wrong somewhere, you can debug it, right? You know exactly what's happening at each stage. You know all the restaurant numbers, the number of restaurants in a city. You know all the types of restaurants in a city. So all that information you can verifiably check. So that's all very useful, right? So that's why it's worth sometimes doing it this way instead of trying to do it in one very clever sort of uh, one liner, right? Sometimes you do a one liner and you don't know why it's wrong or if it is right. You don't know that, right? So this way helps it to be a bit more verifiable, right? So we've got 2 tables now, and they provide different kinds of information. Now the question is, okay, how do I get them together in one table, right? It seems complicated, right? You've got 167 rows here and 2257 rows here, but they have very similar information. But how do I put these 2 together? Right? So that's why I've done it this way, to show you something very useful. Again, this is from an ROE perspective, okay? Because you will get sometimes tables from 2 different sources. In this case, it wasn't. We actually made 2 different tables. But sometimes you'll get a database. There'll be 2 different tables from 2 different even sources. One might be from a PDF, one might be from a HTML, one might be from an SQL. You don't know, right? How do we put this 2 information together? So I'll call this data frame called result, and this function is very useful. Okay, it's called merge, right? So I'm saying pd dot, so it's a pandas function. What do I want to merge? I want to merge city totals. In fact, what I want to do is, no, I want to do city food type first, right? So I'll do city food, yeah, city food. And the other one I want to do is, okay, do I need, I'm thinking, do what, ID city, okay, yeah. I'm just checking if I need to do, okay, right, before I do this much, I just realized something. We don't need all these different food types, right? We actually only need bar food, right? So let's do that first. Before we do the merge, let's create another data frame with only the bar food details that we want. So we'll do on keyboard city cafe, we'll call it, and then do city food. City food dot food type. You guys are following me so far, right? I haven't lost you or anything.
Yes, yes. Follow.
Okay. Okay. So this gives us all cafes from our city food table, because we don't need the other restaurants, right? So in fact, we can even drop the food type label also once we filter out only um, the cafes. So do this. Oops. Food type axis equal to 1. I think that should work. Let's look at it. City cafe. Yeah. So now we have only cafes in those cities, right? So now we can do a merge that is meaningful. So now we'll do that. So we'll say result equal to pd dot merge. So we got two tables. One has our city totals and other one has a city cafes, right? And what I want to do is I want to put the cafe first and the city total next. Okay. Then when you merge two tables, you have to tell it which column you want to merge it on. In other words, what's the common data between them? So of course, in this case, it's the city that's the common information, right? If you remember, this is the number of all restaurants in this city. So Almeida has 130. And if you look here, Almeida has 10 cafes. So that's the merge we want to do. We want to merge it on city. And then the next thing that's very important is to tell how to merge it. So why is this important? So if you look at the number of rows, okay, watch this. So city total has 167 rows, right? So there are definitely more cities than there are cities with cafes, because this has only 109 rows, right? So do I care about the cities? Uh, whether they have what do you call for it? The what's the word I'm looking for? Cities that have um, no cafes, or cities that have cafes. Those are the kinds of things you want to answer, right? So how you do the join will matter. So if I do a left join here, so this is a DBMS idea actually. So if I do a left join here, what will happen is it will look at the left table and it will try and join everything to it. And when it does the join, anything that is not there in the anything that's not there in the right table, it will leave it as blank. Did you understand what I'm saying?
No.
So that, okay. So there are two sets of tables, right? So if I, okay. So you've got two sets of tables. Okay, and you've got other table. Okay. In fact, what I'll do is I'll do it this way around. Okay, so here you got like 1, 2, 3, 4, etc. till like say 9. Okay, And the common column here is those numbers. Okay, so 1, 2, 3, 7, 9 or something. Okay. When you do a left join, okay, on this column, this is the common column. What will happen is anywhere where there is uh, no data, so there are some missing rows here, right? So what will happen is, so there's no row 4 or something. These will be left blank. And that's what gives you a left join. So other ones will be populated with some information that comes from the table. This is what a left join will do. Okay.
But in our case, left join would be ideal, right? Because the our left on left side we have written city cafe, I guess. So
Yes. Yeah. So yeah. So that's what. So but just to demonstrate what it does, that's why I showed you this.
okay,
Now,
okay. So I just got confused that you were convincing us that this left won't work. I got in
no,
that
no, no,
question.
no. Yeah, no,
Okay.
it will work. It will work.
Yes.
So that's what a left join does, right? And right join is the reverse of that, right? Which is if there are more rows in the right side table, then anything that connects to it will go missing again. So in other words, if I did, say for example, if I did a right join here, what would happen is these rows would get dropped out. Wherever there were missing things, it would actually get dropped out if you did a right join. Whereas when you do a left join, it will keep the rows, and anywhere where there's nothing, it will give us none. So two different sorts of behavior occurs basically when you are doing it this way. That's what the left and right joins do. So going back to here, I hope I got that correct anyway. It's late for me as well because I also had quizzes today. So hopefully I got that right. Right. So what are we doing? City Cafe, doing the merge. And we look at the result. So you can see here now, Almeida has 10 restaurants, Almeida that are cafes, that is, and then it's got 130 total. Actually, I should have renamed this column. That would have made things a bit more easier to understand. But you can see what has happened, right? So the left table, which was City Cafe, which was this over here, has gone into this column over here. And then city totals have gone into this column, and the merge is done on the left table, right? And we got 109 rows. So if we did the reverse of it, right? If I did cafe total and what was the other, city cafe, is it? Yeah, city cafe. If I did it this way, notice what the result difference will be. So now there are 167 rows, right? But can you see what's happened on the right side? There are some null values, right? Because those cities don't have cafes effectively.
Right.
So you can see, right, the left join, how it works.
Even if we had written the right join and we had not swapped that city total and city cafe, we would have got the same result, right?
Yeah, we can try it.
Yeah.
Because like I said, it's a bit late, and I'm also a bit not very sharp, but we'll see the result.
Same here, actually. Even if I did not have any quiz,
Right. So yeah, we can see, right, same result, 167 rows, but this time it was a right join. So we got 167 rows, and the nans have come on the left
left
table.
side.
Yeah. So that's something to keep in mind. Okay. So now the next thing is, of course, we want percent, right? But we can't do percent on nans. So what we'll have to do is fill fill any nans with zeros. And in this case, filling nan with 0 makes sense because it means there is no
You have to change that how is equal to right to left, right?
we can leave it for now because we've got the data, right? So we'll replace the nans with zeros. Anyway, we're almost done anyway. So right, so we can see that American Canyon has 3 restaurants, but none of them are cafes. So yeah, so that works. Then we want another column, right? Because ultimately we want to answer this question which says what % of restaurants have or don't have cafes and things like that, right? So all we have to do is, as the usual, we'll create a column saying %, and we'll it'll be, I think, X divided by Y, right? So ID, what that is, it's the dot, ID restaurant X, yeah, divided by the ID restaurant Y. I think that will give us the correct percentage. If we look here, now we got percentages, right? From this, it is pretty straightforward now to answer the question, right? How many cities have a higher percentage of bar food type than Livermore? How many have a higher percentage of burger food than? So I'm not going to solve that because that you should be able to do from now. But the key takeaways, the first important things I wanted to talk about is where was it? So first is this connection engine, right? So you need SQL alchemy, you need the correct connection string. That's usually where most of the errors occur. You might need this PyMySQL because in this case it was required. So this is where documentation will sometimes be useful. But that's easily done. You just put %pip install and it will do it, even on Google Colab. You need a SQL statement. And now some students will put a complex, see, this solution can be actually done in a single SQL statement, believe it or not. You don't even have to do all these things. But for that, you have to be good at SQL, right? If you're not good at SQL, and let's say you use a GPT to get the answer, it'll just give you one very large SQL, which will solve your problem. Great. But do you know it's correct, the answer? That's hard to know, right? In an ROE situation, how do you verify that the answer you got is right? You will get some number, you will think it's right, you'll enter it, and then you'll find out it's not right. Yeah? How do you verify that? That's a challenging thing, right? So unless you know how to write SQL well, it's difficult to debug whether the GPT has given you the right answer or not. Now, I'm not saying it won't give you the right answer. Most of the times it does, but verifiably so, it only comes with experience. So if GPT gives me some SQL, most of the time I'm able to decipher what the SQL is actually doing. So I can trace if there is a bug and where the bug is. But for many people in TDS, that may not be the case, right? They may not have experience of reading SQL. So that's why I'm showing you this simple thing. Get the table you want, select star, which tells select all columns from, because this course is not a DBMS course, right? So that's why I told you that site name, SQL Zoo. Learn some basic SQL there, that will help you. So select star, select columns from which table, and we wanted that table, so we got the information. I put it into a pandas data frame using this command to read SQL, where you have to give it the SQL statement and the connection engine that it's using. So you give those two parameters and it will give you the data frame. We got it into a nice data frame. And then I've demonstrated two very useful pandas functions called group by. And you can group by many levels. So in this case, we group by city, and here we group by city and food type. And anything else we have dropped because that can cause issues if you're having columns that are not necessary in your group by. And when you're giving a group by, remember you have to give some sort of function, right? A group by and do what? Count, you can do count. Average, you can do average. And you can do various other mathematical aggregation functions, okay? So just keep that in mind. Whenever you're doing a group by, you also have to give it some sort of aggregation function. And so that's what it does. And then I showed you another very important thing is you got two tables. they have some common column on which they can be joined. You can do a left join and a right join on it, and then that gives you the merged table, and then you can do something useful with that, right? So we did a simple mathematical operation and then came out with this, and then this will be able to help you answer the questions. So that covers all of week 4 really. Any questions at this point?
Not about graded assignments.
Okay. Any questions on anything else before we close this session?
I wanted to know about that question number 13 on project 1.
Yes.
Yeah,
So
exactly. I
I
had the
have,
same question.
yeah. So I've emailed Anand, and we still don't have an answer to that. Unfortunately, not at this stage yet. I'll probably try and see if we can get some answers to that on Monday.
Okay. And even that at the rate sign I mentioned last time,
Yes.
that is not
So
affecting answers, but again, how should be the approach? I just wanted to know.
yeah, my take is, so when we were solving, I'm just saying from our internal review perspective. So when we were solving, we actually stripped all the at symbols out.
Yeah, same I did.
Yeah, and we, like you said, we get the correct answer, but I think because there might be something on the script side of the server. So on the server that Anand uses, he does everything via JavaScript, not like us. He doesn't use, generally he doesn't use Python. So I don't know if the at symbol causes some parsing difficulties for certain situations. I don't know. So that's maybe why he said to strip the at symbols so that the validation on his end is cleaner. But I'll give you a definitive answer as soon as I find out.
I don't see any post from Anand sir.
No, yeah, I
Yeah,
haven't seen a post on from him either.
yeah, because I
Um,
think his fellow students only answered that post.
yeah,
Yeah,
so I've still not managed to find a resolution for that yet. But as soon as I
okay,
find out, we'll post that on Discourse
sure.
and make it known to everyone as well. But thanks for posting on Discourse. That's helpful
Yeah,
because I know he also reads all Discourse posts. So at some point
yeah.
he'll come across it, and once he decides what is the correct resolution to that, then we'll be able to inform everyone about it. Yeah.
Just one thing for this question. What are the things may go wrong? I mean, which we can try out and see if it is
You're talking
giving the
about
correct
project?
answer. Yeah, project. That particular question, 13.
Question 13.
Like at the red signs and spaces.
Uh,
Yeah.
See, the problem is, even we, as in the TAs, both the Jivraj and I, we have tried that question, and we have had,
Hmm.
I believe what one of the things that we had an issue with was true and false, I think it was it? Let me just have a quick look. Let's see here. Oh, I have to sign in here. Right. So if I look question 13, this was the bios, isn't it? Yeah. So yeah, we also had an issue with this question. We weren't able to get the answer that was expected. So we are, it's an unresolved issue at the moment for us.
Okay.
Yeah. So I can't really suggest something because if I knew the answer, I would tell you what to do, right? In
Fine.
terms
Fine.
of how to
Fine. No
approach it.
issue.
We've tried many different things. Okay. We tried all
Okay.
sorts of, combinations and permutations, and we were not able to get
Okay.
what is the expected answer. So I actually need some feedback from Anand to actually be able to tell you what the issue is. I mean, we
Yeah.
don't know if it's a scripting issue on the server or what. So I can't really. give you any reasonable guidance. But here's the one thing I will say: whatever answer you get, just if you think that's the right logic and you've done it correctly, submit that answer, whatever it is.
Yeah.
Yeah, that's my best
Yeah.
advice I can give you, because
Yeah.
sometimes what may end up happening is we may figure out, okay, there are two ways to solve it the correct way, and if students answered either of those ways, then we will give points for both those ways. You see what I mean?
Yeah.
So
Yeah.
that's the best advice I can give. Make sure your logic was right, and if your logic is right, and if there's more than one way to solve it or interpret it, then we will almost certainly tend to give credit for both those types of answers. But if your logic is wrong and you've come up with something completely not in the ballpark, then we can't really do anything about that.
Yeah.
Okay. So as soon as I know, we will let you guys know. Any other questions?
No.
Okay. Was today's session helpful? Did you learn something useful from it?
Yes, definitely.
Okay.
Carlton, just can you please share that date,
Content.
how you separated that decimal date to date,
Oh,
sorry,
yeah, yeah,
time
yeah. Yeah, yeah, yeah.
definitely.
Yeah, I mean,
You
it was
can
just
just post.
a simple, what do you call for it? No, it was an unnecessary function, but it's useful, right? You can see over here. Because this could have been solved just by using the decimal details, but I just thought something useful to see. Sometimes doing things this way just makes life easier. As you saw, the filtering was very straightforward, right? So all I did was made a column called hours, and then I applied a lambda function. So apply is a transformation, right? You're saying transform this column, right? And then lambda x just takes whatever individual values are here in this column. Okay? Because we are looking at the scheduled departure column, it will take individual values and call them x. So think of it like a for loop. So it will go now, each one by one. So the first one will be 0.0833. That will be x. What do I do with this x? So I'm saying I just want the integer value of that x. So then that's what it did. It put out the integer value of x, which was 0 in this case. And where did it store it? It stored it in that row of BH hours. Okay.
But where did you use the date time function? This
I
time.
didn't use this. I thought I might use it, but I ended up
Okay.
not using it. Yeah.
Okay.
So same thing with minutes. I did a little more complex transformation here. So you can think of it as, when we say f of x, right? We say f of x equal to some function, right?
Right,
And
right,
that,
right. I know how lambda works. I
okay,
just wanted to know how did you calculate this minutes part.
yeah. So here I did, so the x value was, so for example, it was 0.0833. I removed the integer part of it. Of course, in this case, it doesn't make any difference. But if it was like 23.983, so I removed the integer part. It was 23, and then we're left with only the decimal, right? 98333. So that I made into 60. So that's the calculation to get minutes, right? And
Yeah,
that's
I
it.
mean 98 out of 100. So how much
Yeah.
out of 60? Like,
Yes.
yeah.
So that gives you 59 minutes. So
Okay. Fine.
of course there are
So
more
one.
complex
Yeah. Yeah.
Sorry?
Please. Sorry.
Yeah,
Continue.
I was going to say there are more complex transformations possible. You don't have to just do mathematical things, right? You can do things in here like an if-else statements also you can put. You can say if x is this, do this. So you can do quite a bit of complex operations inside a lambda function. Okay. So just remember, this is just a simple mathematical transformation. But you can do conditional checks. You can do far more complex things inside a lambda function. But it'll
Mm.
apply it row by row.
Yes, yes. For a column, it applied. It does
Yeah.
that row by row.
Yeah. So who was it, Prajwalit? I think you were asking something just now, or
Yeah, I was
Sai?
just about to ask regarding this again this question number 13. See, in
Yeah,
that there is a mention that what is the correlation of the length of their bio
yeah,
uh, with followers,
yeah.
and the next line is mentioned the regression slope of followers.
Okay, yes. Regression slope of
So
followers on the bio count.
by
Yeah.
word count.
Yeah. So your
So into
confusion is, should it be length in terms of characters or length in terms of words? Correct.
that is mentioned already, I think, in terms of words.
So in one of his
It is basically,
posts,
yeah.
so in one of his posts, if I remember correctly, I think he says it's just length.
It was initially length. Later on, he corrected it to words, I think.
Oh, did he? Okay, okay. I
Yes,
haven't
yes,
seen
yes.
the latest post. When was that post done? Today, is it?
No, that was
No,
long back,
no.
I think.
3 days.
Okay, okay. Maybe I'll have to, like I said, I'll have to confirm it with him precisely. Just give me 1 second. If you've got 2 minutes, I just want to check something real quick before we go. But meanwhile, if you've got any other questions also, just let me know. But
No,
I'll
so
just
here
keep checking.
my question was that I need to write this, correlation or the regression slope in terms of.
This, yeah. It's a regression. Oh, okay, okay. I see. Correlation or regression. Yeah, that's a good point. I didn't realize there were two different things being asked. Yeah, because there are two different things, right? Correlation only goes from -1 to 1.
Yeah.
And then the other one is regression slope. Okay, okay.
Even I had that question, but generally, what I observed in all the questions that whatever is written on the last line, that thing only we have to do. So, uh,
Yeah.
I did the regression slope, but I have tried that correlation thing with length of the bio as well, correlation thing with word count as well. Nothing is working.
No, it is not
Right,
working. That's
right.
right. But
Yeah, I tried.
earlier, this kind of confusion, other questions, this kind of ambiguity was not there actually. It is
Yes, yes.
correlation, in both the lines. In
Yeah,
Yes.
question
yeah.
number say 11 and all. The question number 11 is like that same correlation written on the first line and correlation written on the second line also. But in question number 13, it is correlation in first line and regression in the second line.
Correct.
Yeah.
There is a confusion.
Interesting. Okay. Yeah, again, like I said, I'm not entirely sure what would be so linear regression. Okay. So I think what is expected, okay, this is just my just from looking at the scripts that are used to run the checks. I think what is expected. Just give me 1 second here. Just got to see how those brackets are placed. Hmm, paste here. Okay. So that one goes. Okay. Okay. So I think he does. He's expecting linear regression on the word splits and the followers. And once he does that, he wants a correlation with, not sure
So
with
I
what.
think it should be correlation only because
Yeah, yeah,
normally this kind of thing, it is correlation.
yes. Yeah, I mean, it makes sense, right? Is there a correlation? Because that's the question you want to try and answer, right? Which is, does having more longer bios give you more followers? So
Yeah,
you would
exactly.
find that, so the answer would be a correlation. If it's correlated, you would say yes. If it's not
Hmm.
correlated, say it would make no difference. So yeah, you're right
Yeah.
in that sense. That question is valid. So in the end, it has to be a correlation.
Right.
But the correlation is followers with what, right? Would it be followers with uh,
Like
sorry,
the number of words, if you have more words, you will have more followers. So
yeah,
there is a correlation.
yeah. Okay. Anyway, like I said, this question is very ambiguous. I'll get it clarified with Anand and then
Okay.
we'll see. Okay. I know that was not probably very useful, but it's the best I can do at this stage. You know? I mean, I can't give you anything more.
Yeah,
okay,
yeah.
Unfortunately, yeah. Okay. Anything else? Or we'll wrap it up for today.
Sure.
Yeah.
We can wrap.
Thank you.
Okay. Okay. Thank you, guys. Good night.
Thank you.
Thank you.
Thank you. Good night.